Here's our last example, performing function operations, and we're going to be dividing two functions. So we have f over g of x, state the domain, then evaluate the quotient when x equals 16. So we know we're taking f of x divided by g of x. So f of x is 6x over x to the 3/4. So remember, this is a 1 at the top. So we need to change that to a common denominator. Let's change it to 4 over 4. And so now we have 6x to the 4 over 4 minus 3 over 4. So this is 6x to the 1/4, or you can think about it as 4th root of x. And thinking about it that way, then you know the domain has to be, first of all, x has to be greater than or equal to 0. And actually thinking about the denominator, we can't have it equal to 0. So really, it can only be greater than 0. Okay, so again, you have to consider what is the restriction for our denominator. And so the restriction for the denominator is that it has to be greater than 0. We can't have it equal 0. So domain is greater than 0. So let's plug in 16. So this is 6, 4th root of 16 equals 6 times 2, or the answer is 12. So go ahead and try this last example on your own. Go ahead and pause it. So you're going to divide f of x over g of x. This is 3x over x to the 1/5 power. And so this is x to the first, or think about it as 5, oh, it's not 5 over 5, 3x to the 5 over 5 over x to the 1/5. Then you can subtract the exponents of the like base. 5/5 minus 1/5 equals 3x to the 4/5. Then you can think about the restriction on here. It's the 5th root of x, but let's see. We have the 5th root of x to the 4th power, so we can have all real numbers. So in this case, our domain is all real numbers except x cannot equal 0. Okay, so that's our only restriction here. Now, this is our function. Then all real numbers except x cannot be 0. And so the last thing is plug in 32. So 3/5 root of 32 to the 4th power is 3 times 2 to the 4th power. And so 2 to the 4 is 16. 16 times 3 is 48.